Okay, word problems, that's where we're headed, guys, will often require you to apply the skills learned above or before, right? Once given a rate, you can use it to set up a proportion, which is basically just two equivalent fractions connected with an equal sign. So let's dive in here. If a car travels at 50 kilometers per hour, how many miles can it travel in 7 hours? Okay, so I'm just going to say like this is basically a fact, right? They're starting you off with that. And then they're asking you for how many miles can you travel in 7 hours. Okay. In a sense, guys, in a sense, this is doing the exact same thing that the question that I just did. You know, the one that got you confused? It's doing the exact same thing. I'm like, hey, if this is true, how much can you do, right? How many liters per 100 kilometers? It's basically doing the same thing. So it's kind of setting the stage. So you notice that I need to, the hours is fine in the beginning, but I need to make sure I convert my kilometers to miles. So I'm going to go convert first for 50 kilometers an hour. So I'm going to go 1 mile. I always have to think too, where do I put the mile? It has to go up there. Why? Because the kilometers that are attached to it go in the denominator so I can cancel out the units there. So that, in a sense, and we're not going to round too soon, okay? You have awesome calculators that are really good at letting you copy and paste, right? So I'm going to go that it's this many miles per hour. Right? So now my units are exactly what I want. I want miles and I want hours. And I use that to set up my proportion, right? Set up proportion. Okay, so in this case, it's 31.069 dot 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 miles in 1 hour. So I need to just put on the other side, what do I want? I want to know how many miles I would travel in 7 hours. And let's say the time I would have given you, you know, how far can you travel in so and so many minutes. Well, then you just have to make sure that the rate you convert has miles and minutes, right? So just watch out for that. And in this case, the 7 is down here, so you have to multiply up and divide going down. And you're like, I don't need to divide by 1, but still, that would be the step that you take, right? So that's just times 7. Oops. Previous answer times 7. So that's 217.49 miles in 7 hours. And some of you might have just said, well, I just want to, I'm going to multiply that by 7. Big deal, right? I'm just going to do it. I agree, but sometimes it's not as black and white. So if you just take the rate, set it up, and then see what is it that you're missing on the other side and just cross multiply and divide, then you'll get it right every time. Next. A small boat motor uses 2.4 liters in 3 hours, right? How many gallons will be required to run the motor for 12 hours? Okay. So 2.4 liters in 3 hours. So I need to know my gallons, right? Gallons. So this is a fact. It's important. I want to know how many gallons in 12 hours. Okay. So I'm going to go 2.4 liters in 3 hours. I kind of keep them together. Okay. And then I'm just going to go 1 gallon has 3.79 liters. Cancel the liters. And you should be able to, at this point, I'm going to get you to write that down first and then just pay attention when I compute this, because I want you to start making this quicker, right? So basically, I would multiply across everything is in the denominator. So this 2.4 times 1. No need to do that. Then you go divide. Watch this. You can do this in one shot, but whatever gets multiplied in the denominator needs to be in brackets. So I'm going to go 3 times 3.79, bracket closed, and that is 0.211 ... and we are in gallons per hour. Okay. And I'm not sure. Well, I'm going to use that gallon in 1 hour to ask how many in 12 hours, right? How many gallons in 12 hours? And yes, there are multiple ways of coming up with this. As long as you show me the work, I'm fine with that. I just don't want an answer just to pop up out of nowhere. So it ends up being that I have to multiply that by 12. So the answer is 2.53 gallons in 12 hours. And remember, a gallon has 3.79 liters, so it does make sense that you would need this many gallons in 12 hours, right? Determining the better rate. And now we're going to talk about unit rates. And here's a few things you need to know. Unit rates. Units need to be the same, so convert as needed. Determine the unit rate. You go numerator divided by denominator. I will say this, denominator is equal to 1. If you want to put that next to that second bullet there. State the better rate and by how much. Okay. So if you want an example of rate, if you, for example, you go to the store and you see, right, that a certain cut of meat is $2.99 for 3 pounds, right? That would be a rate. How do you know it's a rate? Dollars and pounds, 2 different units, it's a rate. And how do you know it's a unit rate? You basically go $2.99. I'm going to do the work up here. $2.99 divided by 3. Okay? So you take your calculator, you go 2.99 divided by 3, and you know it's going to be almost 1. Actually, it does round to 1 in this case. Okay? So that would be $1 per pound. $1 per pound. So you're getting it, the denominator is really 1 pound. Okay. Another note that I want to make sure here is when money is involved, find the dollars per unit. So it's always cost divided by quantity. That's what we did here. Okay. Fuel economy is the amount of fuel used per distance traveled, usually stated as liters per 100 kilometers. Okay, so money and fuel are kind of, there's no gray area. That's how we do it every single time. Okay. Okay, and let's do an example right here. The turkey question on page 5. So the key is that you show the work, and unless I give you a clear indicator as to what the units are supposed to be in, it's really free, like you choose how you want to figure out which one's the better deal. Okay. So we have the turkey at Safeway, okay, and the turkey at Superstore. And so which one is better? So let's do Safeway here. I like to do them side by side. Okay? So we just cut it here. See, there's a typo here. This is supposed to be, sorry, no, it's all good. We're good. So there's a turkey at Safeway. So when you are dealing with money, make sure it's cost divided by quantity, right? When you're talking money, the money always goes on top, okay? So Safeway, we're paying 42.89 for 12.8 kilograms, okay? At Superstore, it's $1.49 for 1 pound. Okay? So both of them are rates, both of them have 2 different units. So what you need to do is to make sure they're, obviously the dollars match, so they're both in dollars, but they have different weights, right? Different units for weight. So this is where you decide. Am I going to convert this one to kilograms, or am I going to turn this one into pounds? You decide. I'm going to turn this one into pounds, right? So I'm going to turn my kilograms to pounds. So basically what you do here is you know that, what are we, 1 kilogram has 2.2 pounds. And I'm going to highlight the kilograms, right? It's important that we know that we're doing that for a reason. We're putting the kilograms on top so we cancel these out. Okay. And then let's figure out what that is. At the top, we stay with 42.89. In the denominator, it's 12.8 times 2.2. I have the answer here, but I will still, it's 28.16. Okay, 28.16, and we are in pounds. Here's where I'm going to use a different color, and I'm going to say that this is a rate. Okay. This is what? If the denominator is 1, it's a unit rate. That's the difference. That's the only difference between a rate and a unit rate. Your denominator is 1. So watch what I'm going to do here. I'm going to copy that same. I know it's more writing than you would like to, but you can handle it. So I'm going to, before I make my final conclusion, I'm going to convert this rate into a unit rate. Watch what I do. I basically divide both of these by the denominator. So 28.16, 28.16. That is going to ensure, what's 28.16 by 28.16 divided by 28.16? Just 1, right? That it's going to ensure that I have the 1 pound, because that's ultimately what I want before I compare. And then you go 42.89 divided by 28.16. It's 1.52. See that? $1.52. This is now unit rate. And it's the unit rates, that's when you make a decision. Don't stop here, right? Some students would maybe stop there. It's like, oh, obviously Superstore is cheaper because look, it's $1.49 versus 42. It's like, no, you got to have them both in the same. It's the same amount of weight that we're comparing here. So Superstore is better, right? Not by a whole lot, but your final answer would say answer, right? Superstore is cheaper by, we can do mental math, right? 3 cents. But this is the kicker, sorry. 3 cents per pound. You're saving 3 cents for every pound you buy. Okay, so that's important that you state it like that in the correct units. So we are comparing the unit rates, right? Let me see if I can spice it up a bit here. Yeah, there we go. That is what I'm comparing. So I don't know, maybe just for reference, this is really what I was doing here to get that difference. Like I subtract what the difference is, or I find what the difference is, I should say, and then I make my final answer. Okay. So if you had turned Superstore's rate to dollars per kilogram, that is fine. Your answer would have been different, but that's also okay as long as you show me that work. Okay. Let's be honest, for ACs or tests, that most likely will kind of hint. Like, I want you to find the difference in dollars per pound. And you know, okay, we're dealing with pound here. Pounds, I should say. Which one is faster and by how much? Let's do that example here. So let's call this A and this B. Right? I just want to have a quick way to reference the two different speeds. So we're dealing with speed here. What would you like? What do I have in my key? I think I went kilometers, yeah. So 14.2 meters per second. And I'm just going to, instead of going side by side, I'm just going to work with this one here. And I know that I'm going to deal with the meters first. 1 kilometer has 1,000 meters. So I get rid of the meters. And then I'm going to deal with my time. 1 hour has 3,600 seconds. Cancel, cancel. So I'm at the top, I'm left with kilometers. Bottom, I'm left with hours. So I'm turning my speed, which is in meters per second, to kilometers per hour. So I'm hearing clicking, which is a great sound. Right? So I'm multiplying and divided by 1,000. So I get 51.12, a nice round. 51.12. Watch this, it's kilometers per hour. Is this a unit rate? You bet. It's per hour, right? Unit rate. This is already a unit rate, correct? The 50 kilometers per hour. So I'm comparing the unit rates. If you wanted to convert both of them to like this 50 kilometers to meters per second, go for it. Like, it's fine. Then your difference would be in meters per second, right? So I will say that traveling at 14 meters per second is faster by And somewhere on this piece of paper, I'm actually not that picky as long as you show me somewhere. This one is, again, very easy to do, right? Right, I'm just doing a side note here by 1.12 kilometers per hour. How about you try one here so you don't fall asleep on me? In miles per hour. I'm going to ask you to figure out which one is faster and by how much in miles per hour. Okay. Let's take a little break here. You try that, and then we'll continue with our lesson. All right. Taking it back for a bit here. I don't know if you want to go back to 5 and just check the work here. You could have done it faster. Like if you look at the 1 mile has 1.6093 kilometers, you can just multiply the kilometers by 1,000, but I show you, I guess, the extra step, right? But ultimately, you should end up with 44.74 miles per hour. Okay, and so then you conclude that 20 meters per second is faster by this many miles per hour, and that's that. So some of them are very easy to figure out the difference, and that's fine if you don't need to. You don't need to show the work on the side if you know how to do that. Okay. Next page, page 6. Fuel economy. Which car has a better fuel economy? You've got car A and car B. So it depends on, they are actually both have rates, but none of them is set as a unit rate. Right? I don't know if you noticed that. So I'm going to go car A here. So 32 liters and 500 kilometers. So this is just how I'm going to do it. I'm going to go turn this into gallons and miles. Okay. So 1 gallon has 3.79 liters. Cancel those. I cancel that right away. And I'm going to go that 1 mile has 1.6093 kilometers, and that will cancel out there. So I'm left with gallons and miles. So let's go ahead and figure that out. I actually don't have this. I just added that. You're the first group that is seeing this booklet, so it's a lot less writing for you, I hope. So that's 500 times 3.79. If you did it in one shot, that's fine. And what are we in, right? I always remember gallons, right? And the denominator now stands for miles. Okay. And the best, so this is the rate. I'm going to turn this into a unit rate. I divide both by 1895, really, so that I can have 1 mile down here, and it's 51.4976 divided by that number up there. So that's 0.0271 gallons per mile for car A. This is unit rate. Okay, this is a rate, this is a unit rate. So I don't know if you want to add that to your note, 1895 divided by 1895. Okay. And then the bottom one here for B, you just go 11.5 gallons for traveling 300 miles, right? So what I'm going to go ahead and do is divide both of them by 300, because it's already in the units that I would like them to be, gallons and miles. So I just get, right, I'm obviously going to get 1 mile here, and 11.5 divided by 300, that's 0.0383, and it keeps going. So this is a unit rate. Okay, unit rate, unit rate. Now you're talking. Okay, now they're both in the same units. First of all, it has to be exactly the same units, and best of all, if they're both in unit rates. If you get something to unit rates, even though I just told you, you're probably like, didn't he just talk about fuel economy? Something liters per 100 kilometers, right? If you get it to unit rates and you compare, you're right. Okay, like it's gonna be right regardless of how you do it. So anyways, which one is better when it comes to fuel economy? Using more or less or fewer gallons, right? If you use less fuel to travel the same distance, it's better, right? Like in terms of fuel economy. So car A has the better fuel economy by, and here's where I'm going to use I'm going to subtract them, right? So this minus that, so it's 0.01 gallons per mile. Okay. So this is my final answer. This is where I really see whether or not you understand what's happening there. I'm going to jump a little bit. I'm going to be just because of my time here. I'm going to jump a little bit. I'm going to go straight to page 7. Straight to page 7. Question F there. And so here we're going to calculate cost of something, right? If one can of paint covers 200 square feet, so I'm going to actually circle that because that's important. One can of paint covers 200 square feet, and it will cost this much. It costs this much. Also important. Calculate the cost of painting a room that has a surface area of 500 square feet, also very important, right? For proper coverage, 2 coats are required, 2 coats of paint. And remember that no partial cans can be purchased. That's very important when it comes to renovations and stuff. You can't buy partial, you have to buy whole quantities. You can't buy 2x4s, right? The wood you use to frame, you can't buy a little piece like that. You got to buy an 8-foot piece, right? So same thing here. So I will show you how that is done. Figure out, right? Total surface area to be covered. Right? So that's going to be my first step. Figure out the surface area to be covered. The room has 500 square feet, correct? The walls, 500. So how many coats are you needing? You need 2 coats. So it's almost like you're painting the same room twice. So 1,000 square foot to be painted. Don't jump to the cost right away. Second, cans required. That's the next step you're going to need. So I will say that 1 can covers 200 square feet. This is called proportional reasoning, right? If I need 1 can to cover this much, how many cans will I need to cover 1,000 square feet? Oh man, I didn't think this through. I wanted it to be a decimal. Can you do something for me, guys? Can we change this up here to 180? Just trust me. Change that to 180 square feet because I want there to be a decimal because it's going to be quite common. So basically we're saying now, it's Monday, guys. Mondays and Fridays are bad, so you better make sure you have an eraser with you. 1 can covers 180 square feet. So how many cans will I need to cover 1,000 square feet? Cross multiply and divide, right? So it's 1,000 divided by 180, really. Let's figure out what that is. 5.555556, right? See that? I want you to actually write that down first, right? That you're going to need exactly 5.55 cans. Can you buy partial cans? No. So the minute, if it's 5 point anything, 5.01, you still need to buy that extra can, correct? So we'll say 6 cans. And then the third step is cost. Don't jump to the cost. Some students want to do it right away. That's the last thing you do, guys. Last thing. So 6 cans times, where is the price? $29.99. Okay. So we just go 6 times $29.99. So not 5.5556, right? It's 6 cans. That's 179.94. This is what I wanted to be on there. This is the final answer. Okay. And I cannot teach you everything, guys, unfortunately. Like, you know that time is restricted. So that's why I skipped a few, because there are some examples just in case I have time. but sometimes I just run out. So what is the homework after today? It's this one right here, just at the bottom here. If you want more, see that more, right? Are you hungry for more? There's some textbook questions that you may attempt. I just gave you the answers are at the back of the book. But I would say if you do the workbook, you'll be fine. I will post the key to the workbook in a bit. Okay? Thank you guys. You were